Hey there, Algebra 2. We're going to work on solving polynomial equations. That's why we've worked on our long division and all those things, but today we're going to focus on factoring all over again. But as you can see with the very first problem, since it starts out with x cubed, that means we're going to be up a level of what we have been doing. So we're going to use some old information. We're going to do a lot more work for each problem. Okay, but you guys aren't afraid of that, are you? All right, so here we go. Let's get everything to one side, right? That's always one of our options of something we want to do. So subtract that 3x, but none of these go together. So 2x cubed minus 5x squared minus 3x, it equals 0. I'm looking for the greatest common factor. What do all these terms have? Well, what I notice is they at least have an x, right? Because I don't know how to solve x to the third power at this point in my mathematical career. Well, I do, but you guys don't. So this is a really simple trick here is look for a GCF. If I'm going to take out x, I might as well look 2, 5, and 3. So that's going to be it. So 2x squared minus 5x minus 3, it equals 0. All right, so one thing I like to do right away, and I think it's a really good habit so I don't lose track of what I'm doing here. This x out here means x equals 0. Go ahead and finish that part of it. And now the other part you've been doing for quite some time, right? We're going to deal with 2 times negative 3 is negative 6. What are the factors of 6 that subtract to give you 5? Well, that's 6 and 1, and I need negative 6 and positive 1. So here we go. 2x squared minus 6x plus 1x minus 3 equals 0, and factor by grouping. So out of the first two, I see 2x. I get x minus 3. I need an x minus 3, but I already have an x minus 3, so the GCF must be 1. All right, last thing to remember is these GCFs go together. So my answer in factored form, 2x plus 1 equals 0, and x minus 3 equals 0, because I am after the solutions. So just getting the factors won't be enough. Okay, so over here we're going to add 3, x equals 3. And over here I'm going to subtract 1 and divide by 2. So you can tell that these problems are going to have a little more involved. They're going to combine some of the skills that you have, and you're going to have to use quite a few of them to get through what we're doing. Okay. Eventually in this chapter, we're going to talk about the fundamental theorem of algebra, and that means if it's to the third power, I should get 3 answers, 1, 2, 3. So that means I know I've completed this. These all happen to be real numbers, so that's kind of nice. These would all show up on the graph. All right, next one's very, very similar. Okay, so we're going to move our 6x cubed over, minus 6x cubed. Now I do want them in order, so 3x to the fourth minus 6x cubed plus 12x squared equals 0. And this time the GCF is going to be even better than just x, right? Because it has at least 2 in all of them, so it's going to be x squared. I also look at the numbers and I have 3, 6, and 12, so let's divide it by 3. So 3x to the fourth divided by 3x squared is just going to be x squared minus 2, take away 2 of the x's, I still have 1, plus 12 divided by 3 is 4, and we're going to take away both the x squareds. It equals 0. All right, so I got 3x squared equals 0, right? I want to do this right away. I would divide out the 3. I would take the square root, right? So I'm going to find out that I get 0 and 0. That's 2 of my answers. 2 out of 4 already. That's pretty good. All right, what factors of 4 add up to give me 2? Wah, wah, wah. That's not Charlie Brown's teacher. That means you just can't do it. So that means I can't factor this thing. All right, so what else do we know? Well, we know the quadratic formula, but there was something in between called complete the square. So x squared minus 2x plus blank equals, I'm moving this 4 over by subtracting 4. All right, why am I doing this? Because a is 1 and b is even, so this is going to be a lot faster and a lot easier to manage. All right, so I need negative 2. I need half of that. So x minus 1. 1 squared is 1. So I'm going to add 1 to both sides. So I get negative 3 over here. Next step we're going to take is to get rid of that square by taking the square root. So now I have x minus 1 equals plus or minus I square root 3. And then the last step is to add this 1 over. So 1 plus or minus I root 3. So it all goes together. Okay, so I had 0, 0, 1 plus I root 3, and 1 minus I root 3, because I'm trying to get 4 answers. That way I know that I'm actually done with this problem. I had 2 real ones at the 0, 0, and of course the I stands for the imaginary number, the square root of negative 1. Okay, so you can see we're going to combine a lot of skills. right? All those individual skills we worked on earlier this year, we're now going to have to put them all together. Okay, so that's why we reviewed factoring, and we might be able to throw in, some homework throughout here just to try and review, complete the square and the quadratic formula. All right, let's see what we have next. All right, so this time we have way too many x's, right? But at the same point, I can't really take out, I'm going to move the 4 over while I think about this. I can't really take out x squared and bring it down to x squared because 4 doesn't have any x's. So, but the important thing is this 4 is even. So if that's the case, that means I could factor it like normal by breaking it apart into x squared and x squared, because x squared times x squared is x to the 4th. So that all works out. So as long as it's even, I can still work through this factoring process. Just keep in mind that I cannot do the quadratic formula, because a quadratic formula means that you're talking about a quadratic equation. To get lost in vocabulary, that means it only works for things that are x squared. All right, so what are the factors of 4 that subtract a 3? Well, they're 4 and 1. Okay, I need -4 and +1. All right, well, I noticed the first one is still a difference of squares. So I can make this x plus 2 and x minus 2. And I'm just going to go ahead and set those equal to 0. Right, so that was our factoring. On the second one, when I do x squared plus 1 equals 0, I subtract the 1, and I get x squared equals -1. And then I have to take the square root of it using the square root method. So x equals plus or minus I. So there's 2 answers. This factor right here is going to give me x equals +2, and this is going to give me x equals -2. Too many negatives in there. All right, so I'm supposed to get 4 answers: -2, +2, positive I, and negative I. So I have all 4 of them. All right, so we're going to, added another layer, right? Difference of squares. That was a factoring method. And then also the square root method to solve over here. All right, now we got finally something new. Okay, so that's been kind of like a recap. We're putting a lot of things you already know together. Now we finally have something new. We're going to go with x cubed minus 1 equals 0. All right, so we did difference of squares, and I may have mentioned that there's something else to do with cubes. So here's what I'm going to do. I'm going to write this intentionally, make it look a little bit different, that these are both perfect cubes. Right? I can write 1 as 1 cubed. So one thing that we're going to work in this chapter is memorizing at least the first 4 or 5, maybe 6 perfect cubes. That way you recognize them when you see them. Okay, but otherwise there's nothing else I can do with this problem. So here's how it works. We're going to take the base numbers and we're going to write a binomial that looks just like it. Okay, so x and 1, and it was minus, so I'm going to make it minus. Then what I'm going to do is I'm going to take the first base and I'm going to square it. Then I'm going to take the 2 bases multiplied by each other. So 1 times x is just x. And then I'm going to take the last base and square it. So I'm going to intentionally write this. This is the first time you see it. So I'm going to make sure I write this just like that. You say, wait a minute, Mr. Toll, you left out all the signs. Well, there's an easy solution for the signs, right? We're going to write SOAP. Okay, and what that means is we want the same signs. There's your S. We want the opposite sign. So if this one's minus, I need plus here. And on the end, AP stands for always positive. All right, so I got a lot of signs, a lot of parentheses, a lot of stuff going on there. So let's get the final answer. Here's what it looks like. I got x minus 1, x squared plus x plus 1. All right, well, we're getting close. All right, but the problem is I'm supposed to solve it, right? It has an equal sign. So that's how I factor it. And then I need x minus 1 equals 0. So x equals 1. Out of the other one, are there factors of 1 that add up to 1? No, it's either 0 or 2. So guess what? Quadratic formula out of our trinomial. Negative b plus or minus b squared minus 4a and c all over 2a. -1 plus or minus 1. Remember I said just deal with the sign. So it's minus 4 times 1 times 1 is 4 all over 2. Need a little more space. Here we go. -1 plus or minus the square root of -3 over 2. -1 plus or minus I square root 3 over 2. So I'll take that. Remember in your SATs, we're going to separate this -1 plus I root 3 over 2 and negative 1 minus I root 3 over 2. Okay, so quadratic formula. Man, is there anything in this thing we haven't done yet? Holy cow. All right, here we go. So we got a couple different ones to try here, and they really vary based on some of the things you just saw. So I'm going to give these a little bit of time and take a look at it. As you can see, we're almost done. I just want to make sure we check in on these cubes one more time. So x to the fourth, I'm looking for a GCF, and I can't find one. But since this is even, I can treat it just like a difference of squares. Okay, so I can go x squared plus 4, x squared minus 4. All right, it's a little bit early in the morning. I don't know what time you're watching this, but what we find out is some of these problems are kind of like an onion or a parfait. You might want a parfait in the breakfast, but not an onion, okay? Because the x squared plus 4 is done. Right? I can't do anything with positive, but what it can do is take the x plus 2 and x minus 2. This one has another layer of difference of squares. So I get x squared plus 4, x plus 2, x minus 2. All right, so let's get some answers. So I know out of this x plus 2, x minus 2, I'm going to get positive 2 and negative 2. There's two of them. Out of the other one, we're going to set it equal to 0. Here we go. I just set it equal to 0 here. X squared equals negative 4. Got to subtract it over and then take the square root. Well, what's the square root of negative 4? Well, the square root of 4 is 2. So plus or minus 2. And the square root of negative is I. So you get two real ones, two imaginary ones. And that's how we do. All right, the one in the middle, I see x is in all the terms. So I feel a little bit better about this one because it's not going to have anything really crazy about it. So x cubed, I'm going to move the 8x over by subtracting and add the 2x squared. Wait a minute, I didn't put it in order. All right, now we're going to do this one more time. Here we go. X cubed plus 2x squared minus 8x equals 0. And now I need a GCF because I can't really deal with that odd power. That's the big thing. If it's an odd power to get started, there's probably a good chance that we need to do a GCF. All right, now x equals 0. Remember, I want to get that one right away because I find over the last 17 years, observation, sometimes kids will leave that one out. All right, factors of 8 that subtract to 2. Well, we know that. That's 4 and 2. And we want positive 4 and negative 2. Again, equals 0. We're after solutions, right? We're always after solutions now. X equals negative 4, x equals positive 2, and x equals 0. So I got all three of them, all three of them. All right, the next one's a complete mess, right? Like, what's happening here? So first thing we have to do is clean it up. We just got to clean everything up. So we're going to distribute here. So I get x cubed plus 8x equals 8x plus 8. All right. X cubed is the highest power. I'd like to keep that positive. So let's subtract 8x and 8. All right. Well, here's what I ended up with. X cubed minus 8 equals 0. Great, because we've never done anything with that. So, oh, what'd you say? 8's a perfect cube? Oh, that's fantastic. So let's get to this one. So that's x cubed minus 2 cubed. All right, so there was something we had to do here. We have to write a binomial that looks just like it. Okay, x minus 2. And then I need a trinomial. So I need the first one squared. I need to multiply the two bases. So that's 2x. And I need the second one squared. And then we had to clean up the problem, right? How do we clean up the problem? We use SOAP. Same sign, opposite sign, always positive. All right, but I don't really like the way this looks. So let's clean it up one more time. While I'm doing that, there's a lot of stuff going on. So let's get an answer for this first one. So x equals 2. Let's be done with that. And the trinomial x squared plus 2x, instead of saying 2 squared, let's just say plus 4. All right, now are there factors of 4 that add up to 2? No, right? Not going to happen. Yeah. So what I'm going to do is review complete the square. And what that means is I need this x squared and x together. So I'm going to subtract the 4 to get rid of that guy. So we work down and then back up. So what's half of 2? So that's positive 1. 1 squared is 1. And that means it adds up to negative 3. Then we're going to bring in the old square root. The old square root. The old square root. All right, so I'm going to end up with plus or minus I root 3, and I'm going to subtract this 1 over here to get my final answer. All right, so I got 2, I got -1 plus I root 3, -1 minus I root 3. How many answers was I supposed to get? 3? Yeah, x to the third power. All right, pretty good stuff there. All right, so quick review here of all those things going on. So the first one, I feel like you should be good, right? So please give that a try. If you're in my class, just go ahead and do that in your notebook. Number 2, I need to follow some of the rules that we have with these sums and differences of cubes. Remember, this is x cubed minus 3 cubed. And number 3, I don't have a GCF of the whole thing. So this is just reviewing factor by grouping. X squared, x plus 3. I need an x plus 3 again. So what's the GCF? Fill that out. Let's get some answers out of this as we factor. And then here, these are both to the 4th power. Okay, so the first thing we're going to do is realize that 2 to the 4th is 64. So we can make it x squared plus 8, x squared minus 8. Wait, that's not 64. Silly me. That's just 8. No, it's 16. Oh my goodness. So it's 4 and 4. Notice one of these is another difference of squares. The other one, we're going to have to use the square root method to finish those out. All right, so give those a whirl so I can tell where we're at as we come into class. If you're doing super fantastic with all this stuff, then go ahead and jump into some of this work that will be assigned as homework after our day together. And one thing that I see right away before I let you go is 125x cubed, so that's 5x cubed, minus 3 cubed. Okay, so that's going to take care of the 5x minus 3, but I also need 5x squared. I need to multiply the 2 together, so I get 15x, and then I need 3 squared. So if you're kind of on the fence with that one, I totally get it, and we'll work through those as well. But I just want to show you that they both have to be perfect cubes, and we can proceed from there. All right, we'll work on it in class.